So today we're talking about linear functions. We're going to work on identifying a linear equation. So when we look at an equation, can we tell if it's linear or not? We sort of introduce that with the graphs sorting today. We'll talk about the intercepts, x and y intercept, and 0. And then with our next lesson, we'll start working on graphing linear equations. So again, the graph sort activity, we've already done that in class where we're sorting graphs into either straight lines graphs or some of them happen to be curved, and we notice some tendencies there. And so we're going to use that as we look to try and sort things into linear equations or not. So as we look at linear equations, we have the standard form of equation, and it's ax plus by equals c. Okay, in this, a and b are larger than 0, and they cannot be, so they cannot be negative. They're integers, not fractions. So these are going to be numbers, maybe 1, 2, 3, 4, and so on. Okay, and we'll sort of learn to work with that. But we'll notice that the values, the x and the y, are not squared. So anytime I see something to the second power, I know it's not a linear equation. So down below here, I'm going to move the ones that are linear into one pile and those that are not. So this first one, y equals 5 minus 2x, that is linear. Moving over to the next one, you might notice that we have the x to the second power. So as I see that, I know that one is not linear. So the first part is I'm just sorting them into linear and nonlinear. Then I can take this one, 2 times xy. This right here is not, I have x times y, it doesn't fit the formula up above, so this one cannot be linear, and I'd not be able to move it around to make it into a linear form. This one that I'm moving here happens to be linear, but we would have to move it and manipulate it some to get rid of the fractions. This one here, I have a y, it's not to a power. I don't have an x, and sometimes we'll find that is okay, and so that one is linear. So the 3 equations here on the left side are linear. The 2 equations on the right side of the screen are not linear. And again, my expectation is we take a look at it, have a general understanding, but it might be a little more challenging to fully grasp it, and we'll work on clarifying that as we go. So these are the 3 equations that we identified on the previous screen, and we need to put them into linear, standard form of an equation. Again, that's ax plus by equals c. Again, a and b are numbers, and so what I'm trying to do is get x and y onto the left side of the equation. To do that, I'm going to add 2x to this first one to both sides. And I can't combine 2x with y, so I could just get 2x plus y equals 5. So in this case, the a value happens to be 2. The b value is what's in front of the y. That happens to be a 1. Okay, but that's not an explanation point. That's a 1. So in standard form, this equation would be 2x plus y equals 5. In this next one, as I look at the center equation, there is not an x value. So in this equation, the a would be 0, 0 times x would be 0, so we don't have a value for that particular term in the equation. I do need to get the 2 to the other side, so I can go ahead and subtract 2, and we get 3y equals 2. So at this point, this does satisfy what we're looking for. The value in front of y is an integer, and it's greater than 0. On this last equation that I'm moving here, if we focus on it, I need to get integers, so I need to find something that is larger, or I need to get rid of the fraction. To do that in this one, both fractions happen to have a denominator of 5, so if I multiply by 5 on both sides of the equation, we will go ahead and eliminate the fraction. We know that 5 times 5 on the right side is 25. Distribute through, and we would get 15 fifths x minus 10 fifths y. If we simplify that, that's 3x minus 2y equals 25. And now we're in the form of ax. This happens to be minus 2y, but that's plus negative 2y if you'd like to think of it that way, equals 25. So 3 would be our a, negative 2 would be our b, c would be 25, and we're in the form that we need. Again, this is the first time we're seeing it, so we'll get to practice this tomorrow in class and work through a number of situations. Here, certainly give this one a shot, try them. I'll work through them as well. And again, if it's a linear equation, we can work with it. If it's not a linear equation, you don't need to try and put it into standard form. Standard form would be ax plus by equals c. And this one I need to multiply by 2 to get rid of my fraction, and we'd end up with y equals negative 2. This middle one is not a linear equation, so I can't put it into standard form. Our last one is. We have 5y equals 5x. To get into standard form, I need the x onto one side, so I'll go ahead and subtract 5x, subtract 5x. That would give us negative 5x plus 5y equals 0. You might recall that a needs to be a positive integer, so if we divide everything by negative 1, we'll end up with 5x minus 5y. 0 times negative 1 still is 0. So we're just having to alter the signs, the positive and negative signs in front of these. Okay, the x-intercept. Talking about x-intercepts, that's the point. When we talk about the x-intercept, it's where the graph crosses the x-axis. So I'm going to circle that in the graph down below in blue. And that would be our x-intercept. In this case, it would be negative 4. And the ordered pair for that would be negative 4, 0. The y-intercept is the point where it crosses the graph. And at that point, we're at 0, 3. If we were to put the ordered pair for that. 0 is the x-intercept. And then in our assignment, they talk about finding the 0. Just keep in mind, the x-intercept and zeros are the same. And you can go ahead and take a look at that more if you'd like. A linear function will have at most one x and one y value. Keep in mind, we're dealing with a straight line. Straight line can only cross in one spot on the x-axis, one spot on the y-axis. The exception to that is if we have a horizontal line or a vertical line that happens to be right on the x or y-axis. Okay, so as we analyze graphs, oftentimes we might look for the x-intercept and the y-intercept, and it's important to determine what in the world those means. So here we have a situation, the Palo Alto students can buy ticket booklets for lunch. If we look, they only have 60 tickets. Okay, so we have, the value of the booklet, pardon me, is $60, and we have 20 meals purchased ahead of time. So the x-intercept, if we were to look at that, that's where this line would cut across the x-axis. That would be at 20. The y-intercept is where the blue line crosses the y-axis. That is at 60. Again, 0 and the x-intercept are the same, so the 0 of this graph would be at 20. That's basically where does it come up on the origin. What do the intercepts mean? The x-intercept means that we have 20 meals purchased. Okay, that would be the x-intercept. The y-intercept tells us that $60 is the cost of a booklet. Okay, and we can a lot of times use the labels on the axes. So here, take a look, try and determine the x-intercept, the y-intercept, and we can go from there. And then if you can take a look at what the intercept means. So in this first one, if we were to have a y-intercept, it would be at a negative value. And when we're talking about increasing temperature and time, we can't really have a negative time value. So our y-intercept is at -4. And I should rewrite that as just y on that one. And that means that after 0 minutes, the temperature is -4. So at the start of our observation, temperature is -4. In this one, I have 2 zeros, and it's always a little tricky for students to determine which one is the x-intercept and which one's the y-intercept. One way is to think of this as an ordered pair, and we have in the first one the ordered pair 0, -24, and we can create this if we have to. So at 0, we'd go down somewhere to -24, and I'm just sketching this out quickly, and then at this point we'd be at 12, 0. So we'd go over 12 up 0, and we'd have a line. So x-intercept is 12. So the y-intercept is -24. And if we look at this, the x, when we're over 12, we are at a depth of 0. So after 12 minutes, we are at a depth of 0 meters. At the beginning of our time, the y-intercept, at 0 time, we're at -24 meters. So that kind of wraps up what we're talking about in class, where we'll be working on tomorrow. The assignment's on the board, and we'll definitely work on that in class. Hopefully this goes well. Also, I hope to have a lot more views of the lesson tonight, and we'll see you tomorrow.